Hi, today we are going to present to you the analysis of rainfall data that has been sourced from data.gov.in, which is an open data platform of Government of India. The main goal of this analysis is to get insights of various components of rainfall series and model these components to build model that will provide most accurate rainfall forecast for next 10 months. The temperature data recorded monthly from year 1961 to 2013 in India is considered as external series that would explain rainfall series. The data has been converted to time series format for analysis. The data has been visualized to get an overview of the plot so that we can make some inferences to choose appropriate models. From the visualization, we can clearly see that there is presence of seasonality in this rainfall series. The rainfall series reaches its maximum level in the month of July. However, the trend in the series is not evident. Also, there is no significant changing variance. The series does not have significant autoregressive behavior. We can also see from the plot observations are bouncing around mean level, which depicts that there could be significant moving average. ACF and PACF plot supports inferences we got from visualization, as we can see repeating patterns in ACF plot and few significant lags in PACF plot. To check if the series is stationary, we applied the ADF and PP test, and both tests showed p-value less than 0.05, that is significance level, which shows that the rainfall series is stationary. Temperature series in the data is considered as the predictor variable. The correlation between temperature and rainfall series was found to be 0.63. The temperature series explained 63% change in the rainfall. Pre-whitening process applied on rainfall and temperature series has shown 3 to 4 different lags, which depicted that relation between rainfall series and temperature series is real, and temperature series could be used as predictor variable. Now moving on to the modeling part of the project, various modeling methods has been used, such as distributed lag model, dynamic model, exponential smoothing methods, linear state space model. We have considered accuracy of model based on three parameters: MASE, residual diagnostics, and various penalized methods AIC, AICC, and BIC. The best found model can give us a forecast for next 10 months. Initially, we have implemented distributed lag model with temperature as predictor series, which would explain change in the rainfall series. Optimal lag length Q is obtained from AIC and BIC values, and model is fitted with optimal lag length of Q is equal to 12. Model obtained was significant with MASC of 0.4247 and adjusted R square value of 0.9198. AIC plots of residuals has shown significant lags, and BG test also showed p-value less than 0.05, which depicts that significant correlation present in the residuals. BIF tests also showed that model suffered from multicollinearity. After basic DLM model, KEOC model is implemented, and it is seen that model is significant with adjusted R square value of 0.65, which is less than previous model. Also MASC value 0.93, which is much higher than previous model with lag length 12. Autoregressive models were implemented with various combination of P and Q. It is observed that lags of temperature series were not significant after lag length 2, and hence different lag length values of Q are implemented with fixed P value 1. Also, lag of rainfall series after lag length 5 were not significant, and so we used all combination with P value of 1 and Q value of 5. This approach was followed to avoid over parameterization of the model. In terms of MASC values and residuals checked, model with P is equal to 1 and Q is equal to 5 has shown better results. However, to compare all models of distributed lag models with respect to MASC and residuals values, the distributed lag model with lag 12 was best model among other candidate models. After implementing distributed lag models, dynamic models are used to capture various time series components such as seasonality, trend, cyclic pattern, etc. We have seen that series shows seasonality but no trend and intervention. Initially, model was fitted with first lag of rainfall series with seasonal and trend component, but results obtained from model showed trend component as insignificant component. So for next analysis part, trend component was not taken for modeling purpose. Various lag lengths of rainfall series with seasonality are implemented to check which model is able to capture most of the time series. Dynamic model with first lag and seasonal component has shown MASC value of 0.3263, whereas model with first two lags and seasonal component has shown MASC value 0.3265, which is similar to previous model. Also, we introduced first two lags of temperature series, but both were insignificant, so we omitted X series in the model. However, in terms of AIC values and residuals check model with two lags and seasonal component has shown better picture. This model has depicted p-value of BG test with 0.55, which is greater than 0.05, that is significance level. Hence, we can say that model with two lags and seasonal component has managed to capture time series structure. Model after two lags are not used to avoid over parameterization of the model. We can say from above result that model with first two lags and seasonality is better than other candidate dynamic linear models. We have fitted different models of exponential smoothing. Since there is seasonality but no trend, both halt winters trend and seasonality models is applied. Damp trend is also included. From the time series plot, we identified that seasonality is not changing, hence initially model is fitted with additive component. It is found that additive damped seasonality gives better result among the additive model. From the residuals check, it is seen that both models were not able to capture time series component, as residual plot and adjunct test shows correlation left in the residual. Now if we see multiplicative seasonal model with different combinations, multiplicative seasonality with exponential trend has shown MASC value, but considering all the penalized measures, it seems that model with multiplicative seasonality is the best. When comparing residual check for both additive and multiplicative, we see that model with multiplicative seasonality has best residual picture. Finally, it seems that model with multiplicative seasonality is the best. It has better AIC, BIC and MASC values compared to other Holt Winters model. We have got a reasonably good fit and forecast as shown in the figure. Here we consider state space models. We know that series has seasonality but no trend, hence state space model with additive and multiplicative seasonality are fitted with various combinations. Model with additive error term has the best MASC value, but model with multiplicative error term has better AIC, AICC, BIC values. It also has better residuals. Model with multiplicative error and multiplicative seasonality has MASC value of 0.72. The residual check is also good for this model. From the table we can see that the model additive error and additive seasonality has best MASC value. However, from the residual check we found that it does not capture correlation left in the model. Multiplicative model seems good enough, though it has higher MASC value, but it has given good results for residual check, AIC and BIC. Therefore, M&M model has been chosen for fitting. The fit and forecast for this model seems to be reasonably good. Now it is the time to decide on which model we can use for forecasting. The MASC value of the best model from each of the methods are shown below. From the table we can see that dynamic model with lag 2 and seasonality component has lowest MASC value of 0.324. Distributed lag model has second lowest MASC value. The exponential smoothing and linear state space vector model has considerably higher MASC value. We also need to consider other factors such as residuals before deciding the best model. In the DLM model residuals, we had observed that it could not capture correlation left in the models. In the linear state space vector models, the residual check is good, but dynamic models seem to be the better. When we compare residuals of all models, the dynamic models seem to be the best. BG test conducted suggests that correlation left in the residuals is not significant. The selected dynamic model is fitted and used for forecast for next 10 months. The model fitted is very good as shown in the plot. The forecast follows the original series pattern very closely. This was all about our presentation. Thank you.